The wheel drive controller applies positive and negative to one stator winding pair at a time in order to simulate a magnetic field that is moving around the outer circle. The drive motor temperature sensor circuit is similar to an engine coolant temperature sensor circuit. The temp sensor is a negative temperature coefficient thermistor. As temperature increases, the resistance decreases. The wheel drive controller provides a regulated 5-volt supply through an internal resistor and out to the temp sensor. The other side of the temp sensor is connected to a battery negative source inside the wheel drive controller. The controller reads the input voltage on the line between the resistors. The wheel drive system is an independent system. Although it communicates with the main controller, it doesn't need any of those messages in order to operate. Let me demonstrate. The wheel drive system is an independent system. Although it communicates with the main controller, it doesn't need any of those messages in order to operate. Let me demonstrate. I'll disconnect the main controller here. And now I can turn the key on. Nothing lights up on my control panel because the main controller is dead and he supplies power for the control panel. However, the drive wheel system is still alive and I can move the machine. The point of that is when troubleshooting a problem with the drive wheel system, simplify your thinking. The main controller has nothing to do with it. Just focus on the drive wheel controller, his inputs and his outputs. In a permanent magnet DC motor, it's easy to check to see if the motor has the voltage that it needs in order to work. It's a little bit different on an AC motor, but let's see what a normal output looks like. I'll take my voltmeter leads and I'll hook them up across just one of the pairs of the wires going out to the stator. And I'll put my voltmeter on AC volts. And what I want you to see is it's going to start out millivolts here, but it's auto-ranging meter. It's going to go up into volts AC, and I want you to see what does a normal output voltage look like. As it's beginning to move, I'll hold the pedal full open forward. The voltage you saw across that one pair would be the same on all three pairs, no matter which one you measured. When troubleshooting drive system problems, the first thing you will want to do is check to see if there are any codes. Most of the time, there will probably be a code which will lead you in the right direction. If there aren't any codes, check the status LED operation to see what it indicates. If you still don't have anything concrete to work with, gather more facts. One of the ways that you can do that is to systematically check all of the inputs and outputs one at a time until you find something that looks abnormal. You can compare your measurements with the shop measurements found in the service manual. The shop measurements in the service manual are there to give you an idea of what normal looks like. These were actual measurements taken on a single machine. The measurements you make will likely be slightly different due to the variances in voltmeters, current battery voltage, etc. However, it will still help you to have an idea of what normal should be. The service manual page shown here provides normal voltage values for every wire in the drive wheel controller 35-pin low current connector.